guys, we're now looking at exercise 3G and we're going to use matrices in order to do transformations. We need to know how to reflect in the x-axis, and when we do that, it means that x image is the same as x, whereas y image becomes negative y. Remember that when we reflect, it's the opposite x or y that gets changed to the negative. So we're reflecting the x-axis, meaning we affect the y. So y image becomes negative y. We can write equations out of that, and we can say, well, if we look at x there, or x here rather, x image becoming x, we can have the equation it equals x plus 0y, because we're only thinking about the x at this stage. But for the matrix purpose, we need to consider y as being 0y. When we go to the y image, it equals negative y. In that case, now we have the equation 0x plus negative y. We can make a matrix out of that, just like we do for simultaneous. We see that the x is 1, the y is 0, and then we have 0x and negative 1 for the y. So 1, 0, 0, 1, negative 1 is our matrix there. When we reflect in the y-axis, it's very similar, only that this time, of course, we're going to be affecting the x values. So when we reflect in the y-axis, it's the x values that change to the negative. So x image becomes negative x, while y image remains as y. If we think about what that means for our equation, we can say it's negative x plus 0y and 0x plus y. Put them into a matrix just like above, so we get negative 1, 0, 0 and 1. Let's do an example which deals with the reflections. The question is, find the image of the point 2, 3 under a reflection in the y-axis. What that actually means is that if we have a point on our graph, which is 2, 3, so x is 2 and y is 3, when we reflect in the y-axis, where does that point go? So it's not going to stay at 2, 3 necessarily, it may move. Let's see how we can do it with matrices. So we want to identify the matrix that we should use, and we had that one we just considered in the previous slide, 2 examples there. We are reflecting in the y-axis. It means we're going to be affecting the x values. Remember how that means x image goes to negative x, whereas y image goes to y. Remembering that when we say x image and y image, they are just the points that are created under the transformation. We get our equations of negative x plus 0y and 0x plus y. And then we can create a matrix, which is negative 1, 0, 0 and 1. After a while, you'll be good at just knowing which ones to use. This is our special matrix for reflecting in the y-axis. So that's the one we just want to know that that's what we use for reflecting in the y-axis. We then just set up and solve a matrix. So we have our special matrix there being to identify the reflection in the y-axis, and we multiply that by the point. So the point, the x's go at the top as per usual, the y's go at the bottom. What's that going to equal? Row by column, negative 1 times 2 plus 0 times 3. We get 2. 0 times 2 plus 1 times 3. We get negative 3. Now, we actually need to answer the question there. Therefore, the image of the point 2, 3 under a reflection in the y-axis is negative 2, 3. So we made a little bit of a mistake there. It's actually a negative 2, 3, not 2, negative 3. Let's do another example. We're looking at the image of the point 2, 3 under a reflection in the x-axis now. So once again, we identify the matrix to use. Let's go over the steps of how we get our special matrix for reflections in the y-axis. We know that x image equals x, so it stays the same because the x values don't change, but the y values do become negative. We get two equations, being x plus 0y and 0x plus negative y. From that, we can make a matrix of 1, 0, 0, and negative 1. Notice how when I do this, I actually write the 0 in front of the y, and I actually write the 0 in front of the x here. By doing that, it means that I will not forget that they are zeros within the matrix. It just helps a little bit there. This, as we know, is a special matrix for reflecting in the x-axis. We then want to set up and solve the matrix equation. So all we need to do is multiply our special matrix there by the 0.23. Let's do it. So we get 1 times 2 plus 0 times 3 is 2. 0 times 2 plus negative 1 times 3 is negative 3. So now we actually answer the question and we say, therefore, the image of the point 23 under reflection, the x-axis, is 2, neg 3. We will also do, we'll keep going. We'll do dilations by a factor of k from the y-axis. So now again, if we're dilating in the y-axis, we affect the x values. If we dilate in the y-axis, no, in the x-axis, we affect the y values. So again, this is something where it affects the opposite thing, just like we did when we did the transformations in the previous exercise. So now, let's see how this works. So all your x values become kx. So notice that they've said we're dilating by a factor of k. If that was a factor of 2 or 3 or 8 or something, we would have an actual value for x. We don't, we have k. That's all right. Y image is just normal y because it does not affect the y values. Let's write the equations there. So we get kx plus 0y. Again, I've written the 0y in to help me make sure that my matrix is complete. Here, same thing. I've written 0x plus y because y stays the same. I get a matrix of k, 0, 0, and 1. And this is the special matrix we use when we dilate by a factor of k from the y-axis. And remember, k is some sort of value. It's not k as such necessarily. Therefore, if we dilate by a factor of k from the x-axis, you can probably guess what that's going to mean. Once again, x image stays as x, goes to x, and y image is ky. So we affect the y-axis points when we dilate in the x-axis, as we know. We have two equations, x plus 0y and 0x plus ky. Again, notice how I put the zeros there. I think that's a good idea. It makes it that when I write the matrix there, I have 1 for the x, 0 for the y, 0 for the x in this one, and k for the y. Let's do an example from this. This is example 1a from 3G. It is, I believe, on page 109. The question says, find the image of the point 1, negative 2 under a dilation of factor 3 from the x-axis. What that means is there is a point in f of x graph, or y equals something graph, and that point is 1, negative 2. So it's saying when we dilate by a factor of 3, what does that point become? Where does that point go to? Where does it map to as the image when we do the image equation? We want to identify the matrix to use. So we're doing a dilation by a factor of 3 from the x-axis. We're going to affect the y values. When we dilate from the x-axis, we think, well, the x image will just be x as it was before. The y image will be ky. We write the equations, x is 1, 0y, and at the bottom 0x plus ky. And we make a matrix 1, 0, 0k. And we know that's the special matrix for dilating from the x-axis. Once you get the hang of it, you just can use it from your bound reference or whatever. But you do want to know how it works. We set up and solve a matrix equation. So let's think. We've got our constant, our dilation from the x factor matrix, and now k isn't going to be k anymore. If we look at the question, it says a dilation of factor 3. So k is going to become 3 now. So we have 1, 0, 0, 3. So the only difference between the special matrix there is that k is now 3. We're multiplying that by the point. The point is given to us up there as 1, negative 2. There it is right there. When we multiply that row by column, 1 times 1 is 1, plus 0 times negative 2 is 1. Next one, 0 times 1 is 0, plus 3 times negative 2 is negative 6. So if you leave it like this, you're almost there, but you will not get full marks because you have not answered the question. We want to state what we've found. So step 3 is very important. Actually answer the question. It doesn't need to be as wordy as this, but you do want to have an actual answer. Therefore, the image of the point 1, negative 2 under a reflection in the y-axis is 1, negative 6. So that means that when we put this reflection in the y-axis, our point at 1, negative 2 moves to the point of 1, negative 6. That'll do for that one.